Good day, everyone. Our topic for today is all about access control lists, more specifically, extended access control lists. Our group consists of Christopher Glenn Fernandez, Clarck Lalu, Stephen Quiazon, Russell Soriano, and Kristoffer Chu. Before we go to the main topic, first off, let's discuss what are access control lists.
What is an access control list? Access control lists are simple firewalls that can be applied to Cisco routers. Imagine a lock on the door to a room inside a building. The lock only allows authorized users with a key or access card to pass through the door. Similarly, a firewall filters unauthorized or potentially dangerous packets from entering the network. ACLs work in the same principle, and network administrators use ACLs to stop traffic or permit only specified traffic on their networks. An ACL is a sequential list of permit or deny statements that apply to addresses or upper layer protocols. ACLs provide a powerful way to control traffic into and out of the network. The most important reason to configure ACLs is to provide security for a network.
What does an access control list do? When configured, ACLS perform the following tasks. Limit network traffic to increase network performance. For example, if corporate policy does not allow video traffic on the network, ACLS that block video traffic could be configured and applied. This will greatly reduce the network load and increase network performance. Provide traffic flow control. ACLs can restrict the delivery of routing updates. If updates are not required because of network conditions, bandwidth is preserved. Provide a basic level of security for network access. ACLs can allow one host to access a part of the network and prevent another host from accessing the same area. For example, access to a human resources network can be restricted to authorized users. Filter traffic based on traffic type. For example, an ACL can permit email traffic but block all telnet traffic. Screen hosts to permit or deny access to network services. ACLs can permit or deny a user to access file types such as FTP or HTTP.
And what are the two types of access control list? First, standard ECL and its placement. Standard ECL can be used to permit or deny traffic only from source IPv4 addresses. The destination of the packet and the ports involved are not evaluated. A standard ECL can only filter traffic based on a source address. The basic rule for placement of a standard ECL is to place the ECL as close as possible to the destination network. This allows the traffic to reach all other networks except the network where the packets will be filtered. Extended ECL and its placement. Extended ECL filter IPv4 packets based on several attributes. Protocol type, source IPv4 address, destination IPv4 address, source TCP or UDP ports, destination TCP or UDP port, optional protocol type information for finer control. Like a standard ECL, an extended ECL can filter traffic based on the source address. However, an extended ECL can also filter traffic based on the destination address, protocol, and port number. This allows network administrators more flexibility in the type of traffic that can be filtered and where to place the ECL. The basic rule for placing an extended ECL is to place it as close to the source as possible. This prevents unwanted traffic from being sent across multiple networks only to be denied when it reaches its destination. Today, we'll mainly be focusing on extended ECLs.
What are extended ACLs? For more precise traffic filtering control, extended IPv4 ACLs can be created. Extended ACLs are numbered 100 to 199 and 2000 to 2699, providing a total of 799 possible extended numbered ACLs. Extended ACLs can also be named. Extended ACLs are used more often than standard ACLs because they provide a greater degree of control. Like standard ACLs, extended ACL check source address of packets, but they also check the destination address, protocol, and port numbers. This provides a greater range of criteria on which to base the ACL. For example, an extended ACL can simultaneously allow email traffic from a network to a specific destination, while denying file transfer and web browsing. The ability to filter on protocol and port number allows network administrator to build every specific extended ACLs. For example, an application can be specified by configuring either the port number or the name of the well-known port.
For our next topic, we'll be configuring a sample network with an extended ACL using Cisco's Packet Tracer software. Up next, we'll be going through configuring extended ACLs using Packet Tracer 4.1.1.10 as a base. And the objectives for this activity is to configure both an extended numbered ACL as well as an extended named ACL. Now, as it is right now, the network has restricted specific traffic. And what we're going to do with this activity is we'll allow FTP and HTTP to go through the network. Now, first off, we'll be configuring and applying an extended numbered ACL. Now for this, we'll need to access R1 and go through global configuration. Now, in order to create this access list, we'll need to type in the command access list and specify the number that we'll be using for this access list. So for now, we'll be using 100. And since we're going to permit, we'll use the permit keyword. Up next, what we'll be allowing onto the network is TCP. Put that in. And as of right now, we could actually just filter for PC1 as it says here on the side. And by using the host keyword, we could allow any host. But in this case, any device is allowed that has an address belonging to the 172.22.34.64 network. So we'll be using that. Okay, for the subnet mask, we'll be using a wildcard mask. Now, in order to get a wildcard mask, all you need to do is get the binary opposite of the current subnet mask. So, current subnet mask is 255.255.255.224. And as you see here on the example, the binary opposite of that is 0.0.0.31. So, we'll key that in. Then we'll be specifying the host. And we'll be using the server's IP address, the server. specify it as the host. So that's 172.22.34.62. Now, the next keyword will actually tell us what type of packets will be sent through. Now, we'll be using EQ to match only packets on a given port number. Lastly, we'll key in the keyword FTP. Now that we've already made the access list 100 for this one, all we'll need to do is we'll need to assign. Okay, next up, we'll be creating an access list. Same one, but this time we'll be using it to allow ICMP to go through. And all other traffic is denied by default. Now we'll need to apply this ACL on the correct interface to filter the traffic. So we'll be going through G00 and add it to the IP access group. Okay, we'll next verify if the ACL has been implemented. So let's try it with PC. So we'll be pinging the server. Ping is successful. Next step is we'll check if this PC can access the FTP. As you can see, it can access the FTP now. We'll exit out of that. Now, as a test, as it says here as well, we can try to ping PC1 to PC2. So it's unreachable because the traffic was not explicitly permitted. Okay, up next we'll be configuring an extended named ACL. And we'll name it HTTP only. Okay, now we'll be going through the same thing that we did earlier, but this time the access list has already been named. Instead of using 100, we're using HTTP only. Okay, this will be the IP for PC2. Which uses a wildcard of a 0.0.0.15. Next is the host, which is once again the server. EQ again, but this time we'll be using www, World Wide Web. And like what we did earlier, we'll also be configuring ICMP. Okay, exit out. And then we'll be applying the ACL to the correct interfaces like we did earlier as well. So you notice, instead of using the 100, we'll be using our named ACL. That about does it. All we need to verify next is the ACL implementation. First up, we'll try to see if PC2 can now ping the server. So we get a reply. Now we'll try to check. Using the web browser. Okay. Now since we were able to access the web page, it means that HTTP is now allowed on PC2. So that about wraps up our tutorial for extended access control lists. We hope you found this video helpful, and with that, we'll see you next time. Thank you!